Okay, Zoom folks, can you hear me?
Yeah.
Perfect. Thank you so much. Okay, so let's get started. But we'll wait just a minute for the folks that just walked in to take a seat. The classroom is all weird and messed up today. I don't know what happened, but all of the chairs are in the wrong direction and the tables are messed up. So all right, so a couple of quick announcements. So the exam is mostly graded, but your class only has feedback visible for one of the questions. So can you see my feedback if anybody has looked at it? If you got all the points on that question correct, and I think it was, well, I don't remember which question it was, but if you got all the points on it correct, then you won't see any feedback. But if you missed any points, then you might see some feedback. So I guess if you missed points and you don't see any feedback, just feel free to email me. So then you don't have to, admit to getting a question wrong in the chat or anything like that. But my hope is that you're able to see some feedback if you missed points on it. So I should be able to push the rest of the results out by tonight, and you'll see those, and you'll see all the feedback that's there. Homework 5 is due this evening. We pushed it back by a week. All other deliverable deadlines are pushed back by a week as well. So if you're having trouble with homework 5, there's an example video on ELC. I tagged it optional video, just so you wouldn't force yourself to sit through it. The one thing that I'll say about that is that the lubridate function requires one extra step because the way that the date format is in that data set is not amenable to lubridate without going through one more step. So there were a couple of people that emailed me, and they were able to figure it out with a little bit of a hint. But if you are stuck and you can't figure it out, I've put the name of that function that is inside of lubridate in the slide notes of this slide. So I'm not going to give it to you. I'm gonna if you want to, you can try and figure it out yourself first. If not, look at the slide notes, and you should be able to figure it out pretty quickly after that. And if you still have trouble, feel free to email me as well. But the hint is in the slide notes, just in case y'all are struggling, tonight, and I'm not available on my computer or something like that. There is a new deliverable schedule on ELC. We're a little bit behind on topic area coverage, so we're not going to move into predictive hardcore today, but we're going to spend at least one day, maybe 2 days on visualization before we get into predictive, so that we can create graphs and charts of the sort of predictive analytics work that we do in R, right? So we'll have some examples of that in the next few weeks. So the plan over the next month or so is to spend this week, at least today, talking about visualization in R, and then move into predictive analytics, so linear regression, logistic regression, and then some more interesting stuff after that. That's kind of the plan moving forward. The group project data sets are on ELC, so take a look at them before Wednesday and decide, I don't know, your top choice, maybe your top 2 choices. And we'll go through and kind of assign the data sets in class on Wednesday. I'd prefer it if there's no more than 2 teams on each data set, but we will. Homework 5 is already closed. Homework 6 is already is due today. Okay, so don't submit homework 5 to the homework 6 box. I'm going to open up homework 5 between classes, so like after this class, but before my next class. So somebody remind me at the end of class to do that so I remember, but I will open it back up. Absolutely. I apologize. I did not mean for it to close. Thanks for the heads up on that. So before Wednesday, take a look at the data sets, and then we'll kind of go through and assign them to the different groups on Wednesday. I've also posted the project proposal guidelines documents to ELC as well. That's basically just kind of exploratory data analysis on the data set, and you can do it in Tableau if you like. You can do it in R if you are feeling adventurous or very comfortable with it. I suspect that most of you will not choose to do it in R, but that's available to you. And the full guidelines document I'll post as soon as the proposal is done. Today, the plan is to do a brief demo of the exercise from last week, and I'll talk about how we're able to do that now, and then data visualization on ggplot. So are there any questions about any of the stuff that's coming up?
I have a quick question about exams. You were saying that there was feedback under grades, and mine says dropped. Did I do something?
What that means is that the way that the course is set up on ELC is that your lowest exam is going to be dropped. The way that that's set up on the syllabus is that the final exam is optional, right? So if you take the final exam, then your lowest exam is going to be dropped. And so right now, I guess since you only have one exam score, it's saying that it's going to drop this one. But yeah, so I don't know how it picked this one if the other two are zeros. Maybe right now the way that ELC is set up is that if there's no grade entered, it's not a zero. So this is your lowest exam, so it's dropped. But as soon as another exam score gets added to ELC, so the second midterm, for example, then whatever the lowest one is will be dropped. And then if you choose to take the final exam, whatever the actual lowest of the three is, that one will be the one that's dropped. So that's a dynamic dropped. And right now, ELC just thinks that this is your lowest exam score. So that's what that is. But if you go into the exam, you hopefully will be able to see feedback on the question the written question that has a score by it. If you missed points, if you didn't miss any points on that question, I didn't put anything in the feedback column. But this is the first time that I'm using feedback on ELC exams on a quiz on a question by question level. So I don't know exactly what it looks like on the student view. So I think you have to go into the assessment, which is called a quiz on ELC, to see that feedback.
Is that grade on there? Is that the actual grade, or that's the part I'm confused at too?
Okay, so that grade that you'll see right there is your 13 true, false, and multiple choice questions, plus one graded written response question. So the rest of the written response questions have not been graded yet, which means you don't have points for those yet. So right now, everybody's probably somewhere around a 40. And I hope that, by the end of when I finish kind of pushing the grades, everybody will be, much higher than 40. This is not the kind of exam or class where the exam average is going to be in the 40s, I hope. But yeah, so if you click into the exam, you'll see that only one of them has a grade. Only one of those questions has a grade. You should be able to go in and see all of the questions and all the answers and all of that. You all do it? You know what I'm talking about? Yeah. Do you see the feedback? Yeah, okay, perfect. Okay, so in the class, they confirmed that they see it. So if you don't see it, first step I think would be check with another student, just because on my end it's wonky. The instructor version of the student view is a little bit complex in certain parts of ELC, and one of those is quiz views after the quiz has been taken. So I can kind of point you in the right direction of what to look for, but your best bet is to talk to a student who knows what to look for. But you'll see your kind of true grade probably tonight. Okay, so this was the exercise that we were not able to do last class, and I want to just demo it briefly, just so that we've done it. And the way that we did it, so in my MSBA class, one of the students, clicked the website and it didn't work. We'll see if it works this time, just to see. Well, still didn't work. But they copied and pasted the URL into the Internet Archive, the Wayback Machine, if you're familiar with that website. And the Wayback Machine has the link saved, right? So this is the link that we would have been working on if we were doing the project. And so what we have here is some empty space at the top, some information about where this data comes from, some more information about where the data comes from, and then the data itself, which is white space delimited, right? So instead of trying to make sure that you all kind of have access to this data set, I'm just going to go through the process and kind of demo it, because it's a step-by-step kind of data set cleaning process. Very simple data set cleaning process, but still one that I think is worth the 5 minutes or so that it would take for me to go over the steps. So that is the web page. You will not be able to control click the link. If you copy the link and paste it into, I guess, archive.org or whatever the Wayback Machine page is, then you'll be able to get to a page that looks like the one that I have here. So that's how you get there if you want to do it, if you want to follow along. So the way that we're going to do it is first create a new text file using R. So instead of doing file new script, right? What we're actually going to do is a text file. Now, ultimately, all of these are text files, just with different file extensions, right? And the file extension is how RStudio knows how to handle that file extension. So in this case, we could be working in Notepad or any other plain text editor, but in this case, we're just doing it in R. And so what we're going to do is copy and paste the data, clean it up, and save it as co2.txt. So here's the data. I'm going to Control-C, Control-V it into this text file, right? And we need to do some work to clean it up, right? And the first and kind of most obvious thing that we can do is just get rid of all of this stuff, right? None of this is particularly useful. And then the second thing that we notice here is that some of our column headings have 2 lines, right? Cement production, gas flaring, per capita. And that's going to be a problem for us if we wanted to, continue using a white space delimiter for our reader, right? So the next thing we need to do is turn these into 1-line column headings. So we can call this sem prod instead of cement line production. We'll call it gas flare. And get rid of this, and then per capita. And then we can get rid of that whole entire line. So now we have something, and then we can get rid of this line that's below it as well. So now we have something that looks like a data set. We can see that it is white space delimited, right? So instead of commas in between all the different values, you've got white space. And then there's nothing in this per capita line. But if we go to the website, we'll see that annual sums, or where is it? Population estimates were not available to permit calculations of global per capita estimates before 1950, right? So if we go scroll all the way down to 1950, then all of a sudden we start seeing per capita numbers, right? But we don't have those prior to 1950. So again, the rules of the exercise, we've just cleaned up the file for use with R. We'll save it as co2.txt. So what I'll do is I'll file, save as, and I'll save it on my desktop as co2.txt. So now it's there, and if we look at my desktop, there it is, and it will open with Notepad, and this is what it looks like, right? It's just a text file, plain text, and you can open it up in any text editor that you like. So the next thing that we need to do is then import the data set into R as data, right? So if we go to new file and create a script, then we can import the data. So the way that we'll do that is file import data set, and we'll do it from text reader. And the file is going to be our co2.txt file. So we'll open it up. And we'll see that this is all one column, right? Reader is typically pretty good at figuring out what's going on. In this case, it's not able to figure out what's going on here. And the reason for that is that the default delimiter is a comma, but we can change that to white space, right? And so now the preview shows us that, okay, Reader has interpreted this data set as a set of rows and columns, right? It's a table. And we've got some NA values for per capita, et cetera, right? So now we're at a place at which we can go ahead and import the data into our script. So in this case, I'll just copy it and paste it like this. All right, and then if we can run these files, we have our data set. Now, what we can see when we ran those two lines is that there's some parsing failures, right? So what is that? What are they saying here? They're saying there's 62 parsing failures, and it starts on row 200, and they expected 8 columns, but it turned out that there were 9 columns, right? So we can look at CO2 and get a sense of what's going on, right? It says what, row 200. We'll scroll down to row 200. So it gave us some warnings, right? Right as per capita started, but it didn't actually create any problems. It just said, warning, there's something that we thought was a little bit strange. We didn't, we didn't stop the process. Everything still worked, but we just wanted to let you know that something is a little off, right? And what happened here is if we scroll down to row 200, there's white space after this last number, right? So 0.65, and then there's a little bit of white space after it. And so what you could do theoretically is go in and delete all of this white space like that, right? And then you would be able to suppress those warnings. So now if we were to save this file and then rerun this, right? There would be a few fewer of those, right? Now there's 58 because I deleted 4 of those little white spaces. You don't need to do that, right? There's no reason to do that. And if you wanted to do that, this is not the most efficient way to do it, of course, like going in and doing it manually. But that's what those parsing failures are doing, right? So it's good to be able to kind of figure out what's going on with some of these warnings and error messages that R is giving you because, there's many times where you might need to rely on those to figure out what's going on. So are there any questions about what I did so far? Pretty simple step-by-step, right? Wow. Then the last bit is extremely simple, right? All we need to do is plot year against CO2. So what do we need? Year and total CO2 emissions. So is that year in total probably? Yep. So we'll just use the base function, plot year, total, run that. Oh. And it's going to be CO2, $year against CO2, $total. And it's going to be capital Y year and capital T total. And there was our plot, right? Our total CO2 emissions over time by year. So that is that exercise. And I think that the process of cleaning up the data set is useful so that you get a sense of what it's like to work in white space delimited files. There is at least one of the data sets, I believe, is white space delimited. So that is a thing that you'll have to kind of get used to if you choose that data set. I don't remember which one it is, but it's not, not overly tricky. It's not complicated, but you've got to kind of get a sense of why white space is a little bit different than, comma delimited or something like that. So that is the exercise. And again, the solution video is in the slide notes in case you want to watch it later. You probably don't need to, but it's there for you in case you do. So any questions about that exercise? Okay, so the plan for today is to get into this package called ggplot2. And ggplot2 is the package that we're going to be using to handle visualization, right? So this was our very basic, base R plot for this line graph. But when we start using ggplot2, we'll be able to do a lot more stuff to the plots, right? Make our visualizations look a little bit more sophisticated, etc., right? But since we're working in R, right, we're going to be doing all of this, writing code, right? Writing the syntax, which means that what we need to do is we need to have a good idea of what we want before we start working, right? And that's why our descriptive analytics, module at the top of the class is very useful because it gives us a vocabulary of what we want, right? And so we know what we want and we know why we want it, and etc. And then what we do is we kind of translate it into the grammar of graphics, right? And ggplot2 is the name of the package. So when you install the package will be ggplot2. but the name of the function that you'll call is just ggplot without the 2, right? And so this is it's a very flexible way to create visualizations because it uses what they call Wilkinson's grammar of graphics. And you'll see that some of these things in Wilkinson's grammar of graphics should be pretty familiar to you based on some of the things that we talked about in that first module, right? The descriptive module. So what are the elements of Wilkinson's grammar of graphics? Well, there's the data, right? That's kind of important. If you want to, visualize data, you need some kind of data. And in ggplot2, it's got to be a data frame or a tibble. You can't go in there with a matrix or a vector or one of those more simplistic structures. You've got to go in with a data frame or a tibble, right? And so far, we've been using Reader to read in our data sets. Reader will automatically create a tibble for you, so you don't need to worry about this as a practical matter. Then the next thing that you need is a set of coordinates, a coordinate plane. And so far, most of what we've been doing when we, graph something is on a 2D coordinate system, right? A Cartesian system. But we also have maps, right? Maps are another way to think about how data is graphed onto a coordinate plane. There's also other kinds of coordinate planes, right? There's a polar coordinate plane where you have kind of a point in the middle and then some, kind of radiating space around it, etc. Right? So you've got to think about how the coordinate plane is going to look, right? And then there's some geom objects, and geoms are literally geometric objects that represent the data, right? So points, lines, polygons. So if you want to do, a scatter plot, and you want some of your, scatter, the points to be certain things, right? Different shapes or different images or anything like that. All you need to do is set that image as your geom, right? So you can have a scatter plot with a bunch of different images on it, for example. And then there's an aesthetics element to the grammar of graphics, right? And that is the visual characteristics that represent the data. So one thing that I'll say before we get into it, it's a little abstract right now, I'm sure, but you can adjust sort of aesthetic information broadly, both inside the aesthetic function and also outside of it. So in the aesthetic function, it's only when the visual characteristics represent the data. Otherwise, it's generic and it doesn't actually depend on the data itself. And when we get into it, I'll explain that in a little bit more detail. But just keep that in mind, right? You can set, the color of a line, for example, in 2 different places. If you're setting the color of the line in the aesthetic element, right, then you're saying, okay, the line color matters, right? We're going to distinguish it from another line that's on our coordinate plane, and the 2 lines mean different things, right? So that's, if you were to do that, then you would need to go into the aesthetic element. Then you've got scale, which, you can do a logarithmic transformation or something like that if you need to. I don't think we'll do that at all in this class. There's a statistical function. And so for that, that's what you would use if you needed to bring in a trend line, for example. And that allows you to add a statistical function to the graph itself. And then guides, right? Legends, axis, tick marks, etc. So those are the elements of the grammar. And once you know what you want, all you need to do is figure out what it is, which element of the grammar it is, and then you know where you'll be able to write that code in R, right? We're going to see lots of examples of this, so I'm not going to just turn you loose. And the other thing that I'll say while I'm sort of trying to be reassuring about it is that there's an optional video that I posted to ELC that was my kind of review of ggplot from last semester. So basically, last semester, we did the whole COVID thing, right? We canceled the class starting in the spring, right after spring break. This, I believe, was the last or the second to last lecture that I did before spring break. And so once we kind of picked back up again after, we started rolling online, the first thing that I posted was a review of all of this stuff for, last semester students who hadn't, thought about this stuff for 3 weeks. So that's the video that I posted to ELC. So it's, if you're deciding whether to watch, to rewatch a Zoom call that we've already been on or watch that, I think that other video might be a little bit easier to process. Okay, so ggplot, right? We said this was It's the mainline function, right? And ggplot creates a plot, and the plot can be assigned to an object. It doesn't have to be, right? So if you wanted to, put the little arrow in and assign it to an object, you can do that, but you don't have to. And if you don't, what'll happen is the plot will just show up in the plots window, like it did here, right? We didn't assign this plot to an object, but we can, right? So then once you have your ggplot function, you then need to specify the data and you need to specify the aesthetics. And each of these things are kind of layers on top of the base ggplot, right? So let's look at an actual example of this. So here's some code, which I already have in R. So let's zoom in just a little bit so you can see. But this is, it's copy pasted from the slides. So it's all right here, right? So the first thing that we're going to do is I'll maybe clean this up. We'll load in reader because we'll be using it to pull in our data set for this sample, and ggplot2, right, which you'll need to install if you haven't already done so. So remember, the name of the package is ggplot2, and when we actually call the function, it's going to be ggplot. So the data is going to be carbonmeans.txt from Rick's server, and we'll read it in with read_dlim from the URL, and our delimiter is a comma, right? So here's carbon. It's right here. It's our years and our average CO2s. This was our merged data set where we had our years and our CO2 numbers from Central Park, right? That's what we're dealing with. And so what we're going to do first is our base ggplot, right? So what we have here is ggplot, right? We're going to call them the base function. And then what we can see in the tooltip is that the next thing that we need is the data, right? And the data is going to come from carbon. So you can see it in the tooltip. The first thing it asks you is data. The first thing we have there is carbon, right? And then the next thing that we have is the aesthetics, right? And what did we say the aesthetics were? They are the visual characteristics that represent the data, right? And so in this case, we need to say, okay, X and Y, what are they? How do they represent the data? So in this case, X is going to be year, Y is going to be CO2. And so this is our aesthetics, right? This is our full ggplot function. And then we need to add a layer that has the actual G on, right? Because if we have, if we only have this, then all we have is the plot, like the base plot. The default is our XY coordinate plane. We've told it that X is going to be year, Y is going to be CO2. But what we haven't told how we're going to do is actually how we're going to plot out the data that matches up with that kind of blank square, right? So the line that's highlighted basically gives us a blank square with X is year, Y is CO2. And we know that those columns are coming from carbon, right? So the next thing is we need to add the plus, and the next layer is G on point, color, and then you can set the color. You don't have to, right? Color equals red. So if we run this, now we have something that looks a little bit nicer. We got a little bit more control, right? We'll get deeper into this as we move on, but you can see that there's a bit more going on here. And of course, like I said, I can get rid of color equals red, right? This is optional, and it would just show up as black, right? But in this case, I've added color equals red so that you can see that this is a color, right? But the color is not specified inside of the aesthetic function. The color is specified inside of the point layer, right? So what does that mean? The color is not like relevant to the data. It's just the color that we assigned it, right? It's like, I don't want to use the word aesthetic because that's the name of, it's a term of art inside of ggplot, but it's only for, let's say, decorative functions, right? The color equals red in this case is purely decorative, but what we'll see in another example is that we could add color inside of that aesthetic line and that aesthetic part, right, the parentheses, and if we did that, then color would be meaningful, where you'd say, okay, one line is this color, one line is some other color, right? But when you put color under the G on point layer, that says that color is purely decorative, right? We're just going to set the color to be red, right? So that is this very first example. Do you have any questions? Maybe you will after you see more examples. All right, let's do one more example, and then we'll see. We'll kind of come back and see how things have been. So let's see. I think that this is on the same slide, right? Oh, no, this is not on a slide. So the next thing that I have here is that I've just added another geom, right? So far, this is exactly the same, right, as the first line of the last one. But what I've done here is instead of doing just geom points with color equals red, in this case, I've said first we're going to do a geom line with color equals red, and then we're going to do geom point with color equals blue, right? And the thing is that we can add as many different geoms as we want, as long as we just kind of keep building them and it makes sense for them to be on this plot, right? So the plot is an XY coordinate plane. It's coming from the data set carbon. X is year, Y is CO2. Now, what kind of sort of geometric objects make sense on this? Lines, points, etc. These things do. So if we run this, right, you can see, let's zoom in, right? What we have here is a red line and blue points. And so that matches up with what we added, right? We had a layer for the line, a geom object layer for the line, and then another geom layer for the points, right? And it put them right on top of each other. We specified that they'd be two different colors. So then the next thing that we can do is add some axis labels. And so again, this is going to be just the points. And then we'll just add plus and then say, okay, X label is going to be year and Y label is going to be CO2 parts per million in the atmosphere, right? So this line is exactly the same. Though you can see that what we've done is we've eliminated, X equals and Y equals because R knows what those are, right? So I'm kind of, tapering things down over time. But what do we have at this first line? It's ggplot, it's the data, and then it's the aesthetics, right? The default plane is the XY plane. It's not a polar plane or anything like that. So X is year, Y is CO2. That's just like an empty box, right? And then we're going to add some geometric objects. Those are going to be our red points. And then we're going to add some axis labels for year and CO2 ppm of the atmosphere. So now we have our red dots, CO2 ppm in the atmosphere, and year as our axis labels, right? One of the things that we've, kind of talked about in a lot of detail in, the beginning of the semester was that we wanted our y-axis to start at 0, right? In this case, we have what we call a high resolution look at the years 1960 to 2010 or 2020 or whenever that is, right? So if we want to look at that data, but not at a super high resolution to make it seem like this is a very high amount of CO2 rise, right? Because we're only going from 320 to 400. It's only going up by 80, right? So then we can add the 0 point on the axis by using y-lim. So what are the limits of the y-axis? 0 to 1,000 in this case, we'll say. But in this case, everything else is the same. So ggplot, carbon is the data set. The aesthetics, what do we need? Year, CO2. Then the geom points, they're going to be red, labels, and then the y-lim. And so now we have from 0 to 1,000, and you can see that we've removed that high resolution look at the numbers from, what was it, 320 to 400 or so. So in this case, I just also want to point out that the way that I move from plot to plot is by clicking the arrows on the little plot viewer. And you can do that, right? But as a practical matter, don't click too much; it'll give you an error message. As a practical matter, you'll either be doing this in a script or in a workbook, so those plots will show up there. And if you really wanted to save them or move them around in your environment, then you can assign them to an object, which we did not do here, right? We don't have an arrow to assign this to anything. All we have is the output is going to show up in the plot viewer. Okay. Any questions about things so far? Let's do a 1 through 5 in chat for Zoom folks. 1 is I have no idea what's going on with all these different layers and stuff. 5 is you explained it for way too long and I totally get it. All right, we are all over the place, which is difficult for me to interpret, but it's also not surprising to me. So good to know. So I'm going to keep explaining it a little bit on the slow side for those of you that are, on the 4 end of this scale, just to make sure we don't lose any 2s. If you're a 2, feel free to, stop me, ask the questions that you have about why things are the way that they are, and I will make sure to re-explain. Thanks for your honesty there, Matt. Appreciate that. Let's see. So you say that you're a -1. Do you mind expanding on it, or do you want to just keep going and see what happens?
I don't even know where to begin. So let's just keep going, and I'll pretend to.
All right. Well, there's lots of resources, and there's that review video on ELC as well. So I would definitely recommend watching that. But so let me do another. Let's do a universal 1 through 5, not to put any particular student on the spot. Before we got to this ggplot stuff, right? Everything we did in R before today. Let's do a 1 through 5 on that, like an honest 1 through 5. No judgment, like judgment-free zone, how are you feeling on that? If it's a 1, please do let me know. If it's a 5, let me know that as well. So just R generally 1 through 5 before ggplot. All right, so it's useful to see this, and we'll have to figure out how to get those 2s at least to a 3. I might have to. Well, I think that working on the homework will help, and then what I'll do is I'll post a solution video to the homework. So after you've kind of struggled with it for a little bit, you'll watch me do it, and I think that will really help as I go through it step by step. Also, if you haven't watched that example video that I posted, which is another YouTube video from my spring semester, I think that one will help as well, right? That's where I go through step by step how to do a problem that's very similar to the homework assignment, but the homework assignment is slightly different, right? So that'll also be helpful as a resource if you haven't done that already. Okay. So the next thing that we'll do is we're going to compute a new column in Carbon, containing the relative change in CO2 numbers, right? So this should be very familiar, right? What are we going to do? We're going to create Carbon $rel CO2, and then we can assign that to the expression, right? The math expression. Carbon $CO2 minus 280 divided by 280, right? So that's relative change. And so again, the carbon $CO2 means that the data set is carbon, the column is CO2, and then you minus 280 divided by 280. And then that output of this line turns into a new column inside of carbon, right? So you run this. Now we have 3 variables, one of which is the relative increase in CO2, right? So now we can plot that. And we can say, okay, what is the relative change of atmospheric CO2, according to our 280 parts per million baseline, right? So again, we're going to use ggplot. So the function is ggplot. The data is carbon. Here's our data set, right? Now we have this new column here, rel CO2. And then the aesthetics are going to be year and rel CO2. So that's year on the x-axis and rel CO2 on the y-axis, right? So now what we have after this first line is we have basically just, well, let's see if it gives us anything if we just run that line without the plus. So this is what we have, right? We have a box, right? Year, rel CO2. It knows where year kind of starts and ends and where rel CO2 starts and ends. So it's giving us some numbers on the side, but we haven't given it a geometric object yet. And so we need to do that in order to put some actual display of data onto the graph, right? So the way that we do that is on that line, we use the plus sign. So now I've got that plus sign there. And so then I'm going to say, okay, on top of this layer, I want you to add a line, right? We've got, we're conveying data on a year x-axis, right? It's over time. data over time is best displayed using a line graph, or at least that's kind of your default line or your default way to visualize data over time. So we're going to use geom_line, in this case, color equals salmon. I don't remember why I did that, but we're going to use a salmon colored line. And in this case, the X label is going to be year, so we're just going to capitalize the Y. And then we'll actually write out relative change of atmospheric CO2 in the Y label. And then we'll set these Y limits to 0 and 0.5. So now when we run this code, we've got our limits, right? We've got capital Y year. We've written this whole thing out. And then we see that the relative change of atmospheric CO2 is going up over time, right? So this is maybe a more useful way to visualize that same information. Any questions about that? Okay, so let's give you a chance to work a little bit yourself, right? Create a line plot using the data in this table. So we've got some years and some population amounts in billions. And so you'll create two vectors, and you will create a line plot using this data. So I'll give you, I don't know, 5 minutes or so to struggle with this a little bit in ggplot, and then we'll loop back in. And about halfway through, I will show you how to create the data. But I'm not going to give you any hints to start with. I'll let you create the data yourself. You'll have to recall how to create vectors, which maybe you do. Maybe you'll have to look at the notes, and then once you have them, you'll plot them in ggplot. Okay, so let's come back and figure out how to do this, right? We have two vectors, fairly simple data. We've got population in billions, 1 through 9 billion, and then a set of years, right? That go out into the future, which means that some of the future years are estimated years, right? So the first things that we'll do is load in ggplot and tibble, right? Because we wanted to create a tibble. And so we're going to first create two vectors, right? So this is very similar to the very first things that we did in R. So the way that we're going to create our year vector is going to be by combining all of the different years, which you can copy and paste out of the slide. And then population, we'll use the range 1 through 9, right? So here's year, and here's population. And then what we'll do is we'll create a data frame using Tibble, and it'll contain year and pop, right? So in this case, it'll be called DF. And so if we look at it, here's what we got. We got year, we got population, and that's our data frame, right? So that's step one. That's kind of it's a blast from the past. That's a review of data manipulation stuff. Now we have to plot this data, right? So the way that we do it is first we have to set up our the blank box, right? The coordinate plane and the data that's going to go on it using some kind of geometric object. So the way that we do that is we call ggplot. We specify what the data set is. In this case, it's going to be DF, right? DF is the name of the data frame, which we created using Tibble of year and pop of our two vectors, right? So ggplot, the data is DF. And then the next argument is the aesthetics, right? We have to say, okay, we have a blank line, right? We need to, or a blank coordinate plane. We need to specify what's going to be on it. So here's our blank coordinate plane. It's going to have year and population on it, right? So we have years from 1800 to 2050, and population in billions, right? So that's what that first line says. It says ggplot, it's the function that we're using to do our visualization. What's the data set? It's DF. And then we need to specify the aesthetics, in this case, our X and Y axis, year and pop, right? And the next thing that we need to do is add our geometric object, right? And so in this case, we're going to use a line graph. Again, we're plotting over time, so line graph is a great choice. And in this case, we've specified the color to be blue. So if we run these two lines, right, we've got year, pop, blue, and we haven't done much else, right? But we can add our labels, right? So in this case, we're going to add a couple more layers. We'll add X label as year, Y label as population, and then the limits on the Y axis will be 0 through 9. And so you can see that I've got plus signs at the end of each line here, so that all of this is read in at once, right? I was disaggregating it by creating those line breaks, right? So that you could only see what each line did kind of cumulatively. But the overall effect, right, is to say, okay, year, population. Now we're going straight from 0 to 9. And you can see that we have our blue line there on our ggplot. So that is this exercise on creating a line plot using this data to create a very simple line graph. So the downside, right, relative to Tableau or Excel, is that it's a bit more work, right? It's especially if you're not familiar with ggplot, which I assume 100% of you have never used it before today. Maybe I'm wrong, who knows? But especially if this is not familiar to you, it's a lot more work, right? To figure out, okay, how am I going to get this done? The benefit, right? The trade-off is, first of all, it's free. So it's free and open source. So if you're in an organization, you don't need to pay any money for it. If you're a student, I guess we get Excel for free. Tableau, we have a license, right? They kind of they want to push it on you, like they want to get you hooked before you get into the sort of professional space, so that your companies will pay for it. But it is extremely not free, right? Tableau is expensive. R is free. But also you have a lot of control. So you just have to kind of have a good vocabulary in your head of what you want. And then once you think about what you want, you can sort of separate it out into the different elements in the grammar and then decide how to graph it using that grammar, right? So what we'll see is a few different examples of this, of plots in ggplot, to give you a sense of what's possible, right? We could do a whole course on ggplot, and I think that In some kind of stats programs, they do that. But we will stick to maybe 1 or 2 days max. So we'll see a couple of examples of ggplot. So were there any questions on this this exercise before I move on? Did anybody get stuck somewhere and they weren't able to figure out why they got stuck? No? All right. Then we'll move on. So histogram, right? Histogram, we know counts observations. So the y-axis on a histogram is always going to be the counts. The thing about sort of forcing counts on the y-axis is that you only really need to specify the x-axis, right? So you can see that in this code, there's only one aesthetic element that's given. It's the C, which is degrees Celsius, right? So let's go back into R. Okay, so here's our URL, Central Park Temps. I think that this is, okay, Central Park Temps.txt looks like it's okay without adding those comments, so we're in pretty good shape. And so now what we're going to do is, so we've got Central Park Temps. I'll close out some of these things that we don't need. So Central Park Temps is a data frame called T, or a tibble called T, year, month, temperature, fairly, familiar to us, I think, at this point. And what we're going to do is use convunit, right? We did say that we had library measurements in memory, right? So we're going to use convunit to create a Celsius column, right? So we run this column, or run this line, and now we have a Celsius column inside of our table, right? Our table for T. So here is histogram, and it's very simple, right? So ggplot is the first thing. The second thing is the data set. In this case, the data set is a table called T, and then you need to specify the aesthetics, right? And how did we do that before? We said year pop, right? Year is x-axis, pop is y-axis. In this case, all we specify is C, right? That's the only aesthetic element that we specify, because there is nothing on the vertical axis. It's just going to be counts, right? And so when you type in geom histogram, it knows that there's nothing there but the counts. So if you were to break this off and then run that line, right, all you'd have is the Celsius, and there's no aesthetic element on the y-axis, right? But when you use geom histogram, then it knows that what you need to do, what you mean to do, is use count on the y-axis, right? So that is a histogram. And I think in the slides, we say fill equals light blue. So that's one of the things that we can say about a histogram, right? And X label is Celsius. So let's, we can copy this and bring it into R. And so again, now the fill is light blue, the label is Celsius, and it's telling us something, right? It's using bin size equals 30. If you want to change the bin width, you're welcome to do that. And it tells you, use bin width. And so if you go into packages and ggplot, we can sort of look at where that is, ggplot2, and it is geom histogram. So let's look for it here. So here's all of our geoms, right? Curve, density, crossbar, don't even know what that is, contour. So there's lots of different geoms that we can use, right, as a layer, more than line and point. So here's histogram, right? And if we wanted to set the bin width, that's stat equals bin. So we can look at bin width equals, in this case, whatever we want it to be. So if we wanted to set the bin width, we could do that. In this case, we're just using the default bin width. In this case, is 30, right? But if we wanted to check it out, it's telling us that there's an option. And then, of course, we can always go into the help and look at all the different examples of all of the code there, so we can get real deep into histograms if we wanted to, right? If you wanted to create a very specific histogram, you have much more control than you do in R. Okay. So the next thing that we need to do is pull Superstore, which I did not pull, but it's on ELC, I believe, right? So let me grab Superstore. Maybe I do have it. Okay, let's see if I can find Superstore real quick, and then I'll post it to ELC. Oh, is there one there?
Yeah, I'm pretty sure it's under descriptive analytics on ELC.
All right, I missed it. I found it in my downloads folder, so I'm glad that you all have it. I've got it too. Then we can get back into it then. Perfect. Okay, so we'll read Superstore into memory. In this case, the way that we did it was file import data set from Excel, right? Which uses read Excel, which is a function that lives inside of Reader. In this case, I think I had a copy in my downloads, right? So we'll call superstore.xlxs, open. There it is, right? And instead of just clicking import, I'm just going to copy and paste these lines. So copy, and there it is, right? Which we already have it there. So read Excel, ggplot2, and now we've imported an Excel file. We've got Superstore there. And this is kind of our running example for in-class stuff, right? So Superstore. So let's create a bar graph. So in this case, the next one that I have on the slides is a standard bar chart, right? And so the way that we'll do that is first library read Excel, Superstore. In this case, it's wherever it is on your computer. That I think this is where it was on my Mac. And then you can view it if you like, but we'll ggplot, right? That's the function. Superstore is the name of the data set. And then we'll do aesthetics, right? X is category. We didn't specify a Y, which means that we are kind of defaulting to counts. But instead of using histogram, we're going to use geom bar, right? So what does that do? Well, the big difference is that it gives you spaces in between the bars, right? Because one of the conventions for histograms is that histograms, the bars are all kind of squished together, right? In this case, the bars are bars. So we have Superstore, the data set, category, geom bar, fill is chocolate. And that gives us our 3 bars in our bar graph, right? And counts on the y-axis. And this is, of course, what it looks like in Tableau, which, hopefully you remember, right? Very similar to what it looks like in R. So we can flip it, right, by using chord flip. Because one of the things that we said, right, is that we are specifying this coordinate plane. And in this case, we're not going to change the plane. We're not going to use a different plane entirely. We're just going to flip the plane that we have, right? So in order to do that, all we need to do is add one more layer. So in this case, ggplot, Superstore. In this case, we're using subcategory instead of category. So we'll have all those different subcategories of office supplies. And then we'll use a gold fill on our geom bars. And so let's do that before we flip the coordinates. So we'll see it vertical bars, right? You've got all these subcategories. This is a mess. Even if you zoom in, you look at it kind of in its original size. It's not super easy to read, right? So you've still got some words that run into each other. It's not great. But one of the things that we know is that if we flip it on its side, then those words that are a little bit longer will be on their side. So that's okay, right? That'll make it look a little bit better. So we just add chord flip to just flip the coordinates. We do that, and then now we have a horizontal bar graph, and we can see all of our different subcategories in much more detail, right? So that's how we go from a vertical bar graph to a horizontal bar graph. Now in this case, we can use a different coordinate plane altogether, right? A polar coordinate plane. That's what we would call a radar chart, right? So let's say you wanted to create, you wanted to use that same, you wanted to take the same data, right? But you wanted to visualize it in a way that was just more confusing. And you wanted to set it up on a polar coordinate plane, right? So in this case, it's the same information, right? So we're taking basically the same thing that we had. So ggplot, superstore, the X is going to be subcategory. Then we have geombar, fill equals whatever color it is. It's the same thing here, right? ggplot, superstore, X equals subcategory. Around backticks, we've got backticks around it, so it's a non-standard variable name. Geombar, fill equals, in this case, bisque instead of gold. But instead of going straight to the fill, we change the coordinate plane to a polar coordinate plane, right? And that gives us this kind of radial effect, so that you can see, the relative number of products in each subcategory. So the way that we do that is we just add chord polar, and you can do that to any graph, right? You do that, chord polar, and now it's in polar coordinates. So again, haven't tried this, but let's try it on a histogram, right? Is there such thing as a polar coordinate histogram? I don't know, but we'll see if it's something that R can handle, right? So what is the line? Chord polar. I'll go ahead and copy it so I don't make any mistakes. Okay, so here's our histogram, right? Well, there it is. Let's see what happens if we add chord polar to that. Let's see if we can create a polar histogram. Well, we got one, right? It looks like it's a mess, but we did the exact same, graph. We just changed the coordinate plane, right? Which we can do. And now we have this, right? Not great, but it shows you the flexibility of using ggplot above and beyond Tableau, right? Because Tableau kind of protects you from yourself a little bit, right? But my hope is that you feel confident in your own ability to decide what is and isn't useful, right? And if Tableau doesn't let you do something that you want to do, R and RStudio will 100% let you do that, right? So if you want to do something, you can figure out how to do it in R if you understand the underlying elements of the grammar of graphics. So let's do a 1 through 5 and chat again. See how we're feeling. 1 through 5. ggplot. How are you feeling on ggplot? You sort of get the aesthetics, the first line, and then the different elements on top of it that kind of layer on top of each other. All right. The numbers seem lower than they were before, which it's a non-scientific estimate, but you'll have a homework assignment where you have to practice this a little bit. So you'll get some work in. Are there any specific questions? I guess I shouldn't just move on after commenting that the numbers seem lower. Is there a specific part that seems more confusing, or a place where things break down? Something you want me to explain again, or is it just kind of you got to look at it with fresh eyes? You got to look at it a couple more times and figure it out. Somebody just left the class. They pieced out. All right, we're down from 20 to 19. I don't know who that was. Maybe they had a good reason for it. Not to call them out. I don't know who it was. All right. Let's do a couple more, and then we'll take a pause, and we'll come back to this next class. So here's a scatter plot, right? And in this scatter plot, there's something a little bit new that's happening, right? Before, whenever we added color inside of our geom object, right? So geom bar, then we said, okay, the fill is going to be bisque, right? We had a line. We said, okay, the line is going to be color equals salmon, right? So that was always in our geometric object. With the scatter plot, right, here, we don't necessarily care what the colors are. I mean, it's nice to have a good color scheme and all of that, but what matters is that color represents product category, right? Color has meaning above and beyond just its sort of its decorative value, right? So in this case, the aesthetic line is a little bit more complex than it was before, right? So we have ggplot, again, standard. Superstore is the data set, that's standard. And we open up our aesthetic argument and we say, okay, what are the aesthetics? X is profit, Y is sales. And then we're gonna put color inside of aesthetic. And we're gonna say color equals category, right? So it lives inside of aesthetic. And then we have to say, we need a layer for the geom point. We don't specify color inside of geom point, right? So here, if we just run that first line, right? We have everything except our actual points, right? So we have our X, we have our Y, we have our, the data that's going to go inside of our X and Y. It defaults to a standard plane. What is it? It's called Cartesian, right? Is that the name of the plane? It's like a standard XY squares, right? I think it's Cartesian. Maybe that's something different. I don't know. It sounds right. But that's all we have, right? Then we add our points. And then R says, okay, here's what we did, right? We added your points and we took color and we set them up as categories, right? So that is the same, you've seen this, I think, in Tableau, right? Where we compare sales and profit and we, ask the question, does sales predict profit, right? And I think that the way that we did it in Tableau is the Y-axis was probably profit, right?
I have a quick question.
Yeah.
So maybe you went over this already, and I apologize. Why do we have to double or post the ggplot to reflect the colors, like from 102 to 104,
Down
and
here.
99 to 100?
Okay, so your question is, so let's look at 99 and lines 99 and 100, right?
Yeah.
So your question is, why do you double count color? Is that what you said?
Why do you have to double post? I know this sounds elementary, but by 99 and 102 are the same. Why couldn't you just add a plus sign and do geometry point, color blue, geometry point?
You totally can. So what I'm doing here is
okay.
I have kind of I'm working in sort of a sequence. So here, what I have is ggplot, superstore, profit, sales, geom point, right?
Yeah.
So there's no color at all, right?
Yep.
And then I say, okay, let's set color to category. So then we have sort of one step further. And then I have one more where I have geom points as color blue, just to show you what it looks like when you do that, right? And then also geom smooth. So here what we have is we removed color from category. We've put color back into geom point, right? So now color is not meaningful with respect to category, but it is just decorative with geom. And then we've added geom smooth, and geom smooth is a statistical function for a best fit line. So there's 3 different graphs there.
Okay, yeah, that makes sense. So from a -1, I'm a 0 now. So thanks.
Okay, good. I'm glad. That's positive movement. 0 is still a little on the low side, but we'll take it. So yeah, just in case that wasn't clear, these are 3 different plots, right? The first one is superstore and then profit sales with nothing else, right? Geom point. The second one is superstore, profit sales, but then color equals category inside of that aesthetic line, right? And then the next one is profit sales, then the color is tagged inside of the geometric line, not the aesthetic line. And we've also added a geom smooth, which is a geometric object, right? It's a thing that we can see on there. And smooth, and then method equals LM. Perhaps you remember LM stands for linear model, which we looked at last class when we looked at linear regressions. And we said, okay, we're going to use a linear trend line because we know that there's lots of different ways that we can plot a trend line, right? And Tableau gave you half a dozen little options. You can do any of a number of different options for a trend line. And in this case, the method that we're going to use is a linear model trend line. And the color is going to be red, right? So those are 3 different kind of steps of ggplot. So here's where things get complicated. So we're pushing the end of class. I'm going to show you the line graph, right? This is a line graph that has a group by and summarize embedded in it. So this is going to be one of the more complicated things that we'll do overall. And this is where we'll stop today. and then we'll pick this up after next class, right? So here we have Superstore, right? So we're going to read in Superstore, and then we're going to create months and years, right? So Superstore as it is, we've got order date. I think we're going to use order date, right? So we've got order date right here, and we want to pull the months and the years out from order date. I think month and year, right? Order month, order year. So we'll use library LubriDate, and in this case, we'll just say month of order date and year of order date. And now we'll create Superstore $order month and Superstore $order year, right? So if you've already done the homework, you probably recognize that. That's how we pulled out the month and the year. And again, Coffee Chain requires you to take one extra step. If you are struggling about that one extra step, it's in the slide notes, a few slides up, which function you need to call in order to take that extra step, right? But once you've taken that extra step, just month and then that date column, and then you'll pull out the month, year, and then that date column, and you'll pull out the year, right? So then what we're going to do is we're going to group by summarize, right? So we have sales, and we want to group by order month, and we want the sum of sales for each order month, right? We want how much have we sold in each month, right? Overall. And so remember that whenever you do a group by, you need to summarize as well, because you're going to create groups, and you need to create some, you need to specify some method for aggregating within the groups, right? So if you, just like we said when we did group by summarize, we had, all those different years, 12 months inside of them. You compress those 12 months together. You can do the average temperature of those 12 months. You can do the sum of the temperature of those 12 months, etc. You've got to tell R what to do, right? So in this case, monthly sales is going to be Superstore, and we're going to load in dplyr. So monthly sales is Superstore, then your group by order month, then your summarize sales is sum of sales, right? So these are pipes. So monthly sales is your output, your assigned object. Superstore is where you start, and then you have your pipe. Then you're going to group by order month from within Superstore. You're going to summarize the sales as the sum of sales from within Superstore, right? So now we've created monthly sales, and then we can plot it, right? So we've got monthly sales, it's right here, order month, and then we've got the sum of sales, right? That's what we just did. And then what we can do is actually plot that, right? So we'll plot monthly sales, right? So we're gonna refer to our monthly sales table, right? Monthly sales data frame, which has order month and the sum of sales in that order month. And the aesthetics, X is gonna be order month, Y equals sales, right? So in this case, we run this line. What do we have? We have order month, we have sales, right? We can add a point and a line as our geometric objects. And in this case, we want our order months to be, before we said we set up our breaks, right? It was like 0.5s across that x-axis. We don't want that. So we can say the sequence is going to be from 0 to 12 in twos, right? So you get 0, 2, 4, 6, 8, 10, 12. And that's what this scale x continuous is. And remember, scale is one of the elements of the grammar of graphics, right? So you can change the scale however you want. You can do transformations to the scale. You can do all kinds of things to the scale if you would like to. But in this case, all we're doing is we're setting the breaks, right? 0 to 12 in twos. So this is a three-step process. So the first thing that we did was we used LubriDate to pull out the month and the year, which you've maybe seen before. There's a video of it. I kind of, I let you play around with LubriDate a little bit on your own, struggle with it on your own, but guided struggle. And then we used the group by summarize, and this we did cover in class in a lot of detail, using the months that we had to pull out using LubriDate. And then we graphed monthly sales based on our group by summarize. And this is what we came up with. So we'll leave it here for now. We're going to close out visualization next class. So play around with it a little bit if you're still struggling. Look at that review video that's on ELC. I think that will also be very helpful. And then if there's something specific that you are having trouble with, please shoot me an email and let me know what it is, right? And then I can get a sense of how to diagnose that issue for future classes and things like that. Not future classes like next semester, but like next week, right? So that I make sure that I don't lose you next week. So if there are things that you're struggling with, let me know what they are, and I'll make sure that we can kind of patch them up in the next week or so. So I'll see you on Wednesday, and good luck with the homework that's due tonight.
Hey, Professor, I have a quick question.
Yeah.
You might have covered it and I missed it. This is actually just a little bit off topic, but so the BI tools presentation is different from the group project?
Yes, the BI tools presentation is a little bit lighter. It's just basically showing us a tool, right? So like we used Tableau in this class, we used R in this class. Somebody might choose, Alteryx or Power BI, and you'll just do a quick 10-minute presentation on that tool, right?
Okay.
You don't have to use that tool on the actual final project, but the final project will involve you doing analysis on a data set. So I can pull up the proposal guidelines, and so you'll see that, okay, what's the research question? So you've got a data set. You'll have to look at the context and figure out, what's your research question? What does your data look like, right? Describe your variables, do the NOIR thing. And then you'll probably be doing a regression and then do some descriptive visualizations, come up with some hypotheses, right? And then you'll do that process, right? The process of asking and answering a research question on some data. And so the data sets are here in this zip folder, zip archive file. And so they're all just kind of there. And the ones that I've given you are, there's a housing prices one. This is, I think, in Ames, Iowa. If there's any Iowa fans, Iowa State fans. Some life expectancy data from, I think, the WHO. For some reason, there's 2 copies of that file in there. I don't know why. Some student grades. So for both math and a Portuguese language class. And so you can see that there's some information about the mother's education level, the mother's, the parents' income levels, and all these kinds of things. The question that you might ask is, do these things correlate with student outcomes, right? Can you predict which students are going to get better or worse grades based on family size, mother's education, father's education, etc., right? And what else do I have here? There's a health one. There's this Vino Verde one that I talked about before, right? How do you predict whether or not a wine is good or bad in its rating? And the data that we have is acidity, different kinds of acidity, citric acid, sugar, sulfur dioxide, density, pH, alcohol level, etc. And then there's a quality score, and you can say, okay, we want to predict, Vino Verdes that are high quality, and you look at all the different variables, right? And then there's some harder ones in there as well, which I won't get into. But those are the 1 through 5 are sort of set up for a good multiple regression. So that basically what you'll do is you'll go through that process where you ask a research question, you create some hypotheses. So if you're doing Vino Verde, for example, I'll expect you to at least skim a Wikipedia page about wine and say, all right, this is we expect that acidity is going to be important. We think that sulfur dioxides aren't going to matter, right? And here's why. And you can make that up. Frankly, I don't care. But I want some actual grounded in theory hypothesis. And the thing is that it's important to hypothesize before you actually play with the data, right? Because that's the process. If you play with the data first, then you're doing the opposite process. But in this case, yeah. So anyways, that's the long-winded answer to your question, is that you'll pick a data set and you'll kind of do that process. And so far, I've given you instructions on just the proposal. I have the check-in and the final project kind of ready to go, but I didn't want to overwhelm you with them, right away. So I've given you everything that I'm going to ask for your project proposal. So there's kind of 2 group projects that are simultaneous. The tools project is a little bit lighter. It's just do an 8 to 10 minute talk about something, some Power BI or whatever. And the other one is the actual project where you'll actually do analytics on a data set.
And then I was under the impression the fall 2020 data sets was for that BI project. So do you have other data sets for us, or are we just picking our own data sets?
So it is for that. It is for the group project. And so you are welcome to use one of your own data sets if you have one that you like, if you have one from work, you're welcome to use that. Just, make sure that it's okay for you to share with your group, because, you'll probably have to share the data around. So as long as it's not proprietary, then it's fine for you to use. But yeah, so my intention is that you'll use one of these 5 on the final project.
Well, no, I'm talking about for the first initial BIs, data analytics, whatever we come up with for our first presentation. Are we using one of these 6 data sets?
No, you won't need to do actual analysis for that. You'll just show off. So it'll be like you open up Tableau and you show somebody how to use Tableau. You can use Superstore, you can use Coffee Chain, you can use whatever you want.
Okay.
Or you might not be able to do anything, right? If you're showing something that you can't download a demo of, and you have to kind of show screenshots that you take from YouTube videos or from promotional materials or something like that. But the idea there is not to like do analytics using that tool, but more to show the class what it looks like, and then also put it in context, right? What's the market share? What are the industries that use it? Those kinds of questions are the ones that I want you to ask for the tools project, is to give us some sense of what are we gonna, if we encounter this in the wild, right? Let's say we're consulting on a project and our client uses one of these more obscure BI platforms. Then we'll be able to say, okay, I've seen it, right? I haven't used it, but I'm familiar with it. I know that it exists. And I've sort of mentally compared it to Tableau, which is one that I am familiar with. So that's the reason that we're doing this, essentially. Does that
Gotcha.
answer that question?
Yeah, that was good. I just wasn't sure if we needed to use a data set. That was going to be my next question, which is, you can get the free trials, a lot of these, but I don't know how in depth they're going to be. So that clarified that. Thanks.
Yeah, so it's great if you can actually show a live trial. I know that for a lot of them you can't, and so I'm not going to take off points if you can't. Though if you're doing Power BI, I do want to see a live one, because that's one that that's a kind of a special case. But at any rate, you don't have to show a live. You don't have to show a live feed. You don't have to show a live trial. And if you do, you can use whatever data set you want, right? You can use Coffee Chain. You can use Superstore. There's probably a sample data set in whatever the platform is itself. But either is fine.
Perfect. Thank you.
Yep.
I actually have a quick question. When you say like show a live trial for like Power BI, because I'm in the group that's doing Power BI, we are recording these presentations, right? So it would really be like a recorded like demo that we would put in the presentation. Okay, awesome.
Yeah, and ideally, and I guess that these are recorded too. So the way that I recommended them to be recorded is in PowerPoint. So if it's too much of a pain to do a live trial or a recorded trial, you don't have to do that. But I think that for Power BI and maybe Alteryx as well, Alteryx, I don't know how it's pronounced. Those are the 2 kind of most popular alternatives to Tableau. So I think that, those of you that have jumped in and pulled those, you were early to email me and you asked for those, you do have kind of a responsibility to the class to make sure that we do have a good sense of how they work. So do your best is all I say. There's a little bit more pressure on those 2, I'd say.
Oh yeah, of course.
Mm-hmm.
All right, well, thank you so much.
Yep. Mm-hmm. And one more question in class. Yes, the groups are the same for both projects. No, I have time. All right, any more questions on Zoom? Oh, there's nobody there. All right, I'll see you all on Wednesday then.